Today's lesson will answer the question, how can we use exponents to help us calculate numbers that are too large to calculate by hand? Before we start, I want us to clarify some vocabulary. You can see 8 in green is called the base, and in pink we have our exponent, which is 3. So take a moment and look at the relationship between 8 to the third power in exponential notation on the left and expanded form on the right. Those two expressions are equivalent. Now we're going to do some practice with which one does not belong. So for your warm-up, you will choose an expression that doesn't belong in a group with the other three. Then explain why by focusing on what the other three expressions have in common. So pause the video and decide which one doesn't belong, and explain your answer in blue. So now I'm going to go over how to express your answer as an exponent in Peardeck or in Google Slides. So first in Peardeck, you're going to click the T at the bottom, and you can just type both numbers into text boxes. And the nice thing is that then you can just drag your exponent so it's in the correct place. So this example is 5 to the 4th power. And your sentence stem for explaining your answer, if you'd like one, can be doesn't belong because. So you're going to choose one of those expressions. If you choose one with an exponent, you can show it that way. And then you're going to say it doesn't belong because and give your reasoning. In Peardeck, you can also circle your answer by using the pencil icon in the bottom left. Now on to if you're working in Google Slides. In Google Slides, you can add an exponent. I'm still going to use 5 to the 4th as my example, and doesn't belong because as our sentence starter. But in Google Slides, there's actually a place to go under Format to add your exponent. So you can type your answer. I'll use 5 to the 4th again. And once you type it out, you can see it looks like 54. We need to change that. You can highlight the number that should be the exponent, go to Text, and click Superscript. Going back to our warm-up, now that you've paused the video and you've thought about which one doesn't belong and you've explained your answer in the blue box, we're going to think about how to communicate about numbers that are written in this form. So on the left, we have an expression, and we would read this as 2 to the 3rd power. So this is 2 to the 3rd power. And I want you to practice saying exponential expressions correctly because it will help remind you of the meaning. On the right, we have 3 to the 2nd power. And that word power is the same as an exponent. So you can see that in this example, 2 and 3 are our bases. 2 is the base on the left, 3 is the base on the right. And then 3 and 2 on the top are our exponents. And we say an exponent by saying to the power of blank. So on the left, it's to the power of 3, and on the right, it's to the power of 2. So I focused on how we speak about exponents and numbers in exponential notation because your goal on this page is to give your own reasoning why one of the expressions does not belong. So there's not a right answer here. You just need to explain your thinking clearly for your reader. So moving on from our warm-up, we're going to move into our Explore section. And in our Explore section, we're going to look at an example with some context. So we've talked about how to speak about exponential expressions. Now we're going to see how do they relate to a story that we can visualize in our minds. So read along with me for our story about magic coins. It says, Mai and Andre found an old brass bottle that contained a magical genie. They freed the genie, and it offered them each a magical $1 coin as thanks. The magic coin turned into 2 coins on the first day. The coins turned into 4 coins on the second day. On the third day, the 4 coins magically turned into 8 coins, and this pattern continued for 8 days. So if you click where it says click here to open Applet, we can watch this happen. So as you watch the coins doubling, pay attention to the expression at the bottom. That's showing us while these coins are increasing, how we would represent that mathematically. So we're looking at the expanded form on the bottom. Every time we work with a word problem, we want to start with the question, what is this problem about? And that applet helped us visualize what is happening in this problem. Maya and Andre found an old brass bottle, the magic genie came out, gave them a magic coin, the coin doubles each day. Now we have to think about, what is the question asking? So we have two questions on slide C. The first question says, the number of coins Mai had on the 28th day is very, very large. Write an expression to represent this number without computing its value. So think about the examples from our warm-up and the example on the first slide when we talked about 8 to the third power. You can go back to the beginning to look at it again and think, how could we apply that idea to write an expression to represent this situation? And then we have another question on this page, which says, Andre's coins lost their magic on the 25th day. So Mai has a lot more coins than he does. How many times more coins does Mai have than Andre? So now you're going to ask yourself your final question of the 3 reads, which is, what information is important? So looking back over both questions and the given information at the top of this slide, think about what important information will help you answer those 2 questions, and pause the video so you have time to respond in the blue boxes. Now you've had some time to think about both questions. In order to check your work, I suggest you go back and read the questions one more time to make sure you answered the question that was asked. So I want you to especially look at the second question where it says, how many times more coins does Mai have than Andre? You know your question makes sense if you can say that back as a sentence that connects to the given information. So it should say, Mai has blank times more coins than Andre. And if that sentence connects to the information you were given, then you're ready to move on to the next slide. So our final slide, where we summarize what we've been working on today, has us look back to that big question from the start of the lesson. How are exponents used to represent numbers that are too large to calculate by hand? So in our examples at the beginning of the video, we could easily write out 8 times 8 times 8 to also represent the idea of 8 to the third power. But when we got to the story of Mai and Andre, you can see why it's useful in some cases to use exponential notation instead. So as you summarize, think about, how do we use exponents to represent those very large numbers, and explain your reasoning on the right.